All right, greetings everyone. The purpose of this video is to go over a couple of examples of finding the equation of an exponential function given 2 points. Or another way to phrase the question would be to find the equation of an exponential function that passes through 2 specific points. Now, from the materials in class, we know that there are 2 general forms for an exponential function we can use. So there's the f of x equals a times 1 plus r to the xth power, or f of x equals a times b to the x. And in the case of where we are trying to find the equation passing through 2 points, we can use either one of these formulas, but this one here on the right, the f of x equals a times b to the x, is going to be the most useful for us. So let's look at how this would work. So let's suppose that we're asked to find the equation for an exponential function passing through the points 2, 7, and 5, 6. So we're given 2 sets of points. We want to find the equation of the function passing through those 2 points. Now, as was mentioned on the previous slide, to find this equation, we want to use the formula f of x equals a times b to the x. And to write the equation, what we need to do is find the values for a and for b. And once we have those 2 values, we'll fill them in, and that will give us our equation. So using the 2 points, the way we do this is recall that in each point we're given an input value and an output. So for this point 2, 7, 2 would be the input value, 7 would be the output. For the point 5, 6, 5 would be the input, and 6 would be the output. So what we do is we set up 2 equations using one of those points in each equation. And additionally, in the equation, what we do is we put the input and the output from each point where they would go in our formula. So for example, in this formula f of x equals a times b to the x is our input variable, and f of x represents our output value. So for the point 2, 7, in this form, f of x equals a times b to the x, we would input 2 in the place of the x up here. And then we would input 7 or replace f of x with 7 since that's the output value. Okay, so just placing each value where it would go in the equation. Do a similar thing here with the point 5, 6. So we would have, in this case, a times b raised to the power of 5, since that's the input value. And we'd have that all equal to 6, not 7. 6, since that's the related output value. And what we have now are 2 separate equations, but we have 2 unknowns, 2 variables between the 2 equations. And most of the time when we have 2 equations and 2 variables, what we can do, or what that means that we can solve for the values of those 2 variables. So how do we do that first? Well, what I'm going to do is in one of the equations, I want to isolate one of the variables, either a or b, and then I'm going to plug that into the other equation to create an equation where there's only a single variable. So what does that mean? Well, first of all, note that in both equations, a is probably the easier variable to solve for, since it's only to the first power, where the b's have higher powers. And then since the power of b is lower in the left-hand equation, I think it might be easier to isolate a there. So the way that I would do that to solve for a, since the b squared is being multiplied by it, I'm going to divide by b squared on both sides of the equation. Okay, when I do that, that allows me to cancel out the b squareds here. And what we end up with is a equals 7 over b squared. Now note that doesn't actually give us the value for a yet. It just gives us an expression for a in terms of the variable b. And so what we can do with that now, since a equals this, we can take this expression 7 over b squared and substitute it for a in the other equation. So what that'll look like now is we'll have 6 equals, and in the place of a, I'm going to replace it with that expression we found, which is 7 over b squared. And then that's still multiplied by the b to the 5th. And now, even though this looks a little bit messy, a little bit complicated, we see that we have an equation here on the right that only contains a single variable. It only contains the variable b. So that means we can solve for b there. When we have one equation with one variable, generally that means we can solve for the value of the variable. Now, before we begin to solve, I first want to do some simplifying. Notice that we have b squared in the denominator, b to the 5th, and kind of up out of the denominator. So we can reduce those a bit, so I can cancel out the two b's here, cancel out 2 from up here, and that'll become b to the 3rd. So our equation is now 6 equals 7 times b to the 3rd power. And then we know how to solve an equation like this. So since the 7 is being multiplied by the b cubed, we can divide by 7 on both sides. We'll end up with b cubed equals 6 over 7. And then we can solve for b by taking the cubed root on both sides of the equation. Okay, and when we do that, the b squared, or excuse me, the b cubed and the cubed root cancel out. The cubed and the cubed roots, we have b equals the 3rd root, or the cubic root of 6/7. Okay, and then from there we can leave our answer like that as an exact answer. We can also find a decimal value. So let's figure out what that would be. So here on Desmos, I'm going to find the decimal value for this. So I can do this by pulling up my functions here, scrolling all the way to the bottom and using this one with the nth root. So I'm going to find the cubed root of 6 over 7, and it looks like this is 0.9499. And for the sake of accuracy, I'm actually going to go out to 4 decimals here. So I'm going to use 0.49499. Okay, and so I'll take that back here to my slide that has the problem on it. And so we have that b is equal to 0.9499. Okay. And then what we want to do from here is use that value to find the value for a. Now you may think, oh, does that mean we have to start over and kind of do this process again, but isolate a, or isolate b and solve for a? Not quite. Notice that over here on the left-hand side of the screen, we have an expression for a in terms of b. So I'm going to write that up above. So we have that a equals 7 over b squared. And we know what the value for b is. In fact, we have 2 different ways to represent b. So what we can do is plug that in to the expression for a up above. So we could have that a is equal to 7 divided by the cubed root of 6/7, and that would be being the most accurate possible using that. Or instead of the cube root of 6/7, we could input the decimal approximation, which is 0.9499 to the 2nd power. Either way, we can use either of those values to find what a is equal to. So let me again go back to Desmos. I'm going to put both of those in. So the first one was 7 divided by, we had that cubed root of 6/7 raised to the 2nd power, which gives us 7.7576 or 758. If I use the decimal approximation, so the 0.9499 to the 2nd power, notice that we get something very similar. 7.7579 or 758. Notice that both of those answers ran out, excuse me, round off to 0.758. So going back to our slide, we can confidently say that the value of A is 7.7758. Sorry about that. Okay. So now we have the value for A, we also have the value for B. So now we can write our equation. So go back to that form, f of x equals A times B to the x. We just substitute the values we found for A and B. So you have f of x equals the value for A, which is 7.758, times the value for B, which is 0.9499, all raised to the xth power. And that would be our equation. Okay, let's look at an additional example. So here we're asked to do the same thing, to again find the equation of the exponential passing through 2 points. And since we're given 2 points, we will once again make use of that formula f of x equals A times B to the x. We will recall again that in each one of these points we have an input and an output. And so what we'll do is set up our two equations using that information. So one of them, using the first point, -1, 128, the equation will look like 128 equals A times B to the power of the input, which is -1. And then using the other point, we will have 2, which is the output, equals A times B to the second power. Okay? And be very clear that this 2 here, this one's the output value, it's the second 2. This 2 here, that's the input value, that's the other 2. So I want to make sure we're paying attention to where each of those comes from. All right, now something that is different from this problem compared to the previous one is that one of our equations now has a negative exponent. And so we need to recall how to work with that. And so remember that if you have something raised to a negative exponent, like say we have some x to the negative n, that can be rewritten as 1 over x to the n. And basically a negative exponent moves things that are not in a denominator or that are in a numerator, because x to the negative n is the same as x to the negative n over 1, moves them down to the denominator. And it does the opposite if the thing raised to the negative exponent is already in the denominator. So here, if we had something like 1 over x to the negative n, that would be equal to x to the positive n out of the denominator. And again, that means the same as x to the positive n over 1. So what that does for us in our equation over here is that if we have a times b to the -1, we can rewrite that as a times 1 over b. And then we can combine those, and that a is like a over 1 times 1 over b. Well, that's multiplying two fractions, so we can multiply it straight across, which would give us 128 equals a over b. And then from here, this kind of tells us which variable to isolate now. Because since the b is in the denominator, we'd like to get it out. So we can do that by multiplying by b on both sides of the equation. We do, that cancels the b's in the second equation, which give us a equals, then we'll have 128b on the left. Okay, and then just like we did on the previous one, since a equals this, we can take that 128b, drop it in for a in the other equation. So this would look like 2 equals And in the place of a, we'll write 128b times b squared. Times b squared will give us 128b to the third. Can then start to isolate the b there by dividing both sides by 128. Cancel these out. That will give us b cubed equals 2 over 128. Keep that as a fraction, reduce both parts by 2. That will give us 1 over 64. And then we can take the cubed root on both sides to solve for b. And so I'll go back to Desmos here in a second. Find that value for b. So let me clear this stuff out. So here we're doing the cubed root of 1 over 64. And in this case, this comes out as a nice solid decimal, 0.25. That actually looks familiar to me. So I'm going to hit the fraction button, and I see that that's the same as 1/4. So we know now that the value of b from our equation here will be equal to 1/4. And then, just as we did before, now that we know that b equals this, we can use the equation we have for a here to find the value for a based on that. So we have a equals 128 times b. Can rewrite that as 128 times the value we got for b, which is 1/4. And I'll leave it to you to check that if we do 128 times 1/4, we'll end up with 32. So now we have our value for a, our value for b. You can put both of those back into our equation of that form f of x equals a times b to the x. Substitute our values in for a and b, and we'll have f of x equals 32 times the value for b, which is 1/4, raised to the xth power. And that's it. All right, thank you for watching. That's it for now.